Continuing on with section 8.8, we're solving these linear systems by graphing. So at number 2 here, neither one of my systems is solved for y, so they're not in slope-intercept form, which means I either need to solve them for y and use slope-intercept form, or I can use intercepts, and that's what I'm going to do on the first one here. So to find my x-intercept, I plug a 0 in for y, because on my x-axis, my y value is 0. I only want the variable that I'm looking for as far as my intercepts go. So my x-intercept here, x minus 0 equals -3. So I cross at -3. To find my y-intercept, I make x 0. Keep in mind we keep the sign in front of the number with the number. So I have -y equals -3. Number in front of our y, if there isn't one, that coefficient is a 1. So I have -1 times y. I get rid of it by dividing. And my y-intercept is going to be at 3. So I cross my y-axis at 3. Now that I have 2 points, I can connect those with a straight edge. To get my line. And remember, we want to use a straight edge so we get as close to accurate as we can. We also want to extend through our graph because we don't know where our next line is going to cross. So we want a big graph so we can see where they'll meet. My second equation here also isn't solved for y, but here I am going to solve it for y. Again, we could have used intercepts again, but I'm going to solve for y just to get another view of it. So here, I'm getting y by itself, but I also have this -4x that's being added on. Remember, when we solve equations, we do any adding or subtracting first to get rid of anything that doesn't have our variable in it. So I have a -4x. I'm going to get rid of it by adding 4x. So I add 4x to both sides. -4 plus 4 gives me 0. So all I have left is 4y equals. On the right-hand side, I have a 4x plus 12 because I cannot add those together because they don't have the same variable part. 12 doesn't have one, 4 has an x. Now, to get my y by itself, it's being multiplied by 4, so we divide by 4. And I'm going to divide the entire side by 4, which means I can take 4x divided by 4 and 12 divided by 4. Remember, we're going to divide every single piece by that denominator. And I'm going to get just 1x plus 3. I'm going to start at 3 here. And my slope is 1. Again, once it's solved for y, we have y equals mx plus b. My b value is my constant that's being added, the one that doesn't have the x. That's where I start, and it's on my y-axis. And my slope is my coefficient on my x, the number that's being multiplied. Here, it's a 1, which you write as a fraction as over 1. So I'm going to go up 1 over 1, up 1 over 1, and continue that pattern. If we see here, our lines, or our dots end up on the line we already have. So when I go to draw this line in, let me try that again. My blue line is going to end up in the exact same spot as my yellow line. I kept it off just a little bit there so we could still see them both. Now, what that means is that every single point that works for my yellow line or my top line is also going to work for my blue line or my bottom line, bottom equation. So here we call that infinitely many solutions, because every single ordered pair that works for one equation will also work for the other. So here 2, 5 is a solution, 4, 7 is a solution, -1, 2 is a solution, -5, -2 is a solution. Okay, any point that works for one will automatically work for both, because even though our equations look different, they actually mean the same line. In number 3 here, again, if we look at this first example, it's not solved for y, so I can't use slope-intercept unless I solve it for y, or we can use intercepts. So to find my x-intercept, Actually, here I'm going to solve it for y to get more practice with that. I feel like we've done more with intercepts. So to solve for y, I have to get rid of anything that doesn't have a y in it. So my 3x is being added to that. I get rid of a negative 3x by adding. To move it to the other side, we do the inverse operation. So if I have subtraction, we do adding, because that's how I get to 0, and it goes away. So I have y equals, here I have a positive 3x, we put our x first, minus 1. Now, since it's solved for y, I'm in slope-intercept form. I start at my intercept, negative 1, and my slope is 3, so I can go up 3 over 1. Up 3 over 1. I can also go backwards. I can go down 3 and back 1. From there, we're going to connect our dots. To draw in our line. My second equation here is already solved for y. So since it's solved for y, I'm in slope-intercept form. My b value is my 4. My m is my slope. So I'm going to start at 4. B for where I begin on my y-axis. My slope is 3. So again, I'm going to write that as 3 over 1. I'm going to go up 3 over 1. Or I can go down 3, back 1. Down 3 and back 1. When I draw on my line here, we can tell that these are parallel lines. And again, if you're not sure, check. So here on my axis, I go up 1, 2, 3, 4, 5 to hit my other line. Here, 1, 2, 3, 4, 5. I go up 1, 2, 3, 4, 5 and hit my other line. So the change between them is the same every time, which means they're parallel. Here, no solution. They're never ever going to cross. Never going to meet. No ordered pair will work for both equations. We also could have seen that from our equations. Here my slope is 3. Here my slope is 3. And my intercepts are different, which means they're different lines. And that's all I have for section 8.8.